Okay, so let's continue by looking at two types of reflections, vertical and horizontal. So I want to try to do this first. All right, so I want you to think just about the word vertical, not in math, but in life. What do you think of when you think of the word vertical in life? Up and down. Very good. So when you think about vertical reflection in math, I want you to think up to down or down to up. That's how it's being reflected. So if that's the case, all right, if that's the case, what axis are we reflecting across? Very good, the X, which is weird, right? Because most students, when they see that word vertical, they think about a different axis. All right, so that's why I want you to start by thinking vertical is up to down or down to up, so up and down, and that's over the x-axis. All right, over the x-axis. So that's what we call a vertical reflection. Let's think about the word horizontal. In life, what do you think about with the word horizontal? The horizon, right? On the horizon, so left to right. All right, so we're going left to right and right to left. What axis do we cross? The y-axis. All right, so that should help you when you're trying to figure out the difference between these two reflections. So, Mr. Frederick? It's okay. Okay, sure. Everything, like all of our books and stuff? Maybe not. Okay. Just her. You got it. Thanks. Mr. Juarez. Okay. Reflections. Now, let's see what happens when I show you this example. All right? Okay. This is the square root function. All right, it says the square root of t, square root of x, doesn't matter, just some variable. All right, do you guys see how it's half of a parabola? All right, the other half would be here, but the reason it's not is because we can't get negative y values. When you take the square root of 4, the square root of 9, square root of 16, all those y values are positive. So that's why it's half of the parabola. All right, now, you'll see it's talking about a vertical reflection here, all right, because it's going up to down, up to down. Does everyone see that? Up to down. So I'm going to draw that. You don't have to, but I'm going to. I'm going to just plot this real quick to show you that we're going up to down. So up to down. That's vertical. So what axis are we crossing? The x. So across, you want to write this down, the x-axis. All right, I'm going to try to help with your brain here. Let's focus on this point, 4, 2. What does 4, 2 become when I reflect it across the x-axis? 4, negative 2. So which value became the opposite? The y value. All right, the y value became the opposite. Now see if you can follow this, okay? When you think about this function, you have s of t and the square root of t, all right, on each side of that equation. All right, this is the function. What up there represents y? What up there represents y? What is it? Very good. S of t is the same thing as y. So if we're changing the y values to become the opposite, that means the entire function becomes the opposite. So I'm going to write down entire function becomes opposite. If I put OPP, you guys know opposite? Okay? Now here's the last step. The entire function becomes opposite. What is the function? It is the square root of t. So where is my negative symbol going to go to make the entire function opposite? And Yesenia said it on the outside. So this is what the new function would look like if we wanted to reflect it across the x-axis, or in other words, create a vertical reflection. That is not something that you're just going to walk up to someone on the street and say, hey, can I teach you about vertical reflections? That's not something that's really common sense. It takes a lot of thinking about mathematics. Questions on vertical reflections? Okay, let's shift to horizontal reflections. All right? Now, horizontal reflections, this one down here. You'll see that we're moving left and right. In this case, I know it's weird. We're going right to left, but it's the other way. But you got it, okay? So I'll draw the original here. Here's the original. So you can see we're moving from right to left. What axis do we cross? We go across the y-axis. Okay? So let's just use that point again, 4, 2. But this time, what does 4, 2 become when I go across the y-axis? -4, 2. So this time, the value that changes is the x value. So that means instead of making the entire function opposite, what am I going to make the opposite? The x value. So x becomes the opposite. That means I'm going to have the square root, and instead of having the negative out in front, where is the negative going to go? Inside with the x. In this case, it's t, but with the x. Okay, that is a horizontal reflection. Now would be the time to ask questions if you're confused. No questions on how to graph it, how to write it. Okay? All right, let's do one more together, and then we'll transition to the exit ticket, since it was challenging in my other class, so you have enough time to do it. All right? Okay, let's look at this one. Okay, first off, what type of function is f of x? What type of function is this? Absolute value function, because that does the absolute value bars. Okay? Now, this is not a part of the question, but if I asked you, how does the parent function move to get this, what would you say the shift is from the previous lecture? 1 to the right, because it's inside the absolute value. So I'm just going to, for our purposes, write 1 right. Just to help my brain say, hey, first thing I'm doing is actually I'm going 1 to the right. So let's plot it. Let's plot this as f of x equals the absolute value of x minus 1. 1 to the right. So there is my new vertex, 1, 0. And I'm going to make my v. Okay. I'm going to do another color to do my reflections. Let's do g of x. For this one, so g of x. And I believe it says to do the vertical reflection first. Is that correct? Let's do the vertical reflection up here in purple. Okay. So think vertical reflection. Think about the word vertical. What do you think about for the word vertical? Up and down. So that means it's going to go from a V opening up to looking more like what letter? Kind of like an A, that's what I was going for. I mean, not exactly, but kind of more like an A. All right, so I have the same vertex point. That doesn't change, but now we're opening down. Okay, so I'm going to write the absolute value of x minus 1. Now let's see if you can do this. When you do a vertical reflection, if you need to think about a point, you can. Let's look at this point. You guys see, let's see, what is that, 3, 2? All right, instead of 3, 2, what is the point down here? 3, negative 2. So the y value changes, which means what do I need to make opposite? The entire function. Whenever you say I need to make y opposite, that means it's the entire function. So to make this easy on you, I'm going to put a parentheses around the entire function. And outside I'm going to put the negative sign. And leave it alone. Don't try to do anything else. You'll only get into trouble. Questions on the vertical reflection? Okay? So vertical reflection, the entire function becomes opposite. I haven't really thought of like a catchy way to memorize that. Could anyone think of one? Vertical entire function. My brother used to work at Vincent and Elkins. VE, vertical entire function. My brain just did that. Isn't VE one of our sponsors? Does anyone work at VE? No? Vincent and Elkins law firm. Vincent and Elkins, V&E. Anyway, that's how I just came up with it. That got me through college. All right. Green one. Horizontal. Spell it right. Reflection. Excellent. Horizontal reflection. So now I'm go back to the original up here in black. The original is at 1, 0. When I reflect it horizontally from the right to the left, that means my new vertex is what point? My vertex right now is 1, 0. What's my new vertex going to be?
0.
No, 0, -1 would be down here. You're close, Julissa. -1, 0. Just have the order backwards. -1, 0 across the y-axis. Excuse me, across the y-axis. So here it is. Which way is it going to open? It's going to open up. It's going to be a V still, because we're just reflecting it left and right. Okay. Now here comes the fun part. What is going to happen to my function when I write it? When I write it, all right, if we're talking about a horizontal reflection, we can think of some points here. We can start, remember we used 3, 2? What does 3, 2 become now? 3, 2 went all the way over here. 3, 2 went all the way over there. That's -3, 2. So x became opposite. So what am I going to make opposite when I write this? Don't think so hard. Just the x. So it becomes -x minus 1. You guys see how the negative went inside with the x. All right, once you finish writing this, put your pen or pencil down. I want to show you something a little crazy. Just for fun. See if anyone finds this interesting. Can anyone think, and again, you should not be writing what I'm about to write, can anyone think of another way to write the green one? Is there another way you could write the function that's in green? Yeah, Sylvester? No? Okay, sorry, you're just... You absolutely could. Negative parentheses exponent would be... No, because if we did the +1 with the negative parentheses here, it would actually be over here. It'd be the black one. Can you do the green one without any negative signs? Can you do the green one without any reflections or negative signs? Think about where is the parent function? Where is the parent function? At 0, 0, right? Oh, if you're moving here, plus, I think 1, right? Just 1? From the parent, from this one, right here. All right? What's crazy, guys, is these two are the same. Right, Edgar? I had the same thought. How could they be the same? They look so different. They're the same function when you graph it, but they mean completely different things. This one just means you take the parent function and move it 1 to the left. Done. This one means move your parent function 1 to the right, then reflect it across the y-axis. Completely different things, right? But they result in the same absolute value function. All right, so let me pause this.